Thank you, and also good afternoon from my side, and thanks to Mike for the opportunity to speak here and for the nice introduction. So we at Faro, we are in the we at Faro, we have a 13 years history in offering laser scanning for the construction industry, and that's really what we are focusing on. We want to deliver traceable information about construction sites along the whole construction lifecycle and offer information for every stakeholder who needs to work with reality data. And the driver here is really to reduce the cost for waste and rework by allowing our customers to make more informed decisions and have better information to do the right decisions and the right planning. Of course, it all starts with the capturing phase itself. And here we have, first of all, our flagship product, the Faro Focus, which is a stationary scanner which is able to capture pretty accurate data in millimeter accuracy directly on-site and with a very easy-to-use way. If you need to capture bigger sites like highways or roads, then we partner with a company called Ziteco from Italy, which allows you to take the same focus laser scanner but mount it on their Roadmapper Z product, which you see here in this video, and use it for capturing roadsides. And with a similar approach, we just recently announced a partnership with a company called Stormby from Belgium in Europe, which uses our focus laser scanner and puts it on a UAV. And with this solution and the software that comes with it, you can really capture within minutes complex areas like chemical plants or bigger construction sites, which would have taken you otherwise hours or even days if you would have done that with terrestrial stationary laser scans. So that's our latest advancements on the laser scanner. But sometimes a 2D plan is doing the job. And for occasions like that, we just released a few weeks ago a brand new product called ScanPlan, which literally allows you to capture 2D floor plans while you walk through a construction site. And it immediately creates deliverables on the device, which you can export as a floor plan, either in PNG format or as images, or even as DXF or DWG files, and directly create the deliverable on site and use it immediately. Okay, once you have captured all that data, the next question is, what are you going to do with it? And as long as it is about creating as-built design models, we work very closely with the colleagues from Autodesk. And we have two major products here. One is called as-built for AutoCAD, which is a plugin for all the AutoCAD variants and supporting all the industries where you can use AutoCAD in. And this as-built for AutoCAD provides a variety of tools to fit geometric objects into the point cloud to create as-built CAD models from it, like you see it here. So you can create line works or geometric primitives. There are point picking tools which allow you to just simplify the way you generate as-built data from point clouds. And what you can also do is you can use our Send to AutoCAD plugin with our own scene software. And instead of picking points from the 3D point cloud in AutoCAD, you can use the panoramic views in Scene, which provide you a very crisp and very clear two-dimensional picture, and pick points there and then send them directly into your AutoCAD application. And of course, you can also do things like intelligent structural models or piping models, like we see it here in the video. The parallel product to that for the Revit world is called as-built for Revit. And also here you can use the underlying recap point cloud engine and expand its functionality by our tools that we are providing to create intelligent building models. And for example, you can fit wall objects into it using the original Revit objects, creating the intelligence that you need, but having best fit functionalities into the point cloud. And one functionality that I also like a lot is that with these tools, you have the possibility to align the walls. You can define if they should be perpendicular, if they should be in line. And in this way, the software helps you a lot to create a engineering level design model in Revit. And what I like a lot is that with Revit for as-built for Revit, we also provide the use of point clouds in the family editor, which makes modeling of as-built family objects a lot easier than it used to be. And apart from modeling buildings, like with the AutoCAD plugin, of course, in Revit, you can also create structural models and piping models. And that's what we're going to see in the next section of the video here. So you can fit your Revit piping objects directly into the point cloud. You can place elbows and T's, and also valves can be placed. The handles of the valves can be oriented according to the point cloud data. And all that in a very easy and efficient way. And in a very similar way, of course, also steel modeling works based on the point cloud data. Now, once you have finished your CAD model, the question is, how do you bring your design data onto the construction site? And there we also have a tool in the as-built for AutoCAD, which allows you to take specific points or coordinates directly from your design model and send it directly to a robotic total station. And by this, you can use the total station on site to project the points on the site. And then the workers, like we see it here in the video, can use those projected points to mark out the points. For example, positions of drywalls or drill holes, whatever you want to project. And this idea, bringing design into reality, taking a step further, we are currently working on a project with a customer of us called CW Keller, together with the colleagues from Autodesk. And we use our latest laser projector, the tracer. And here we use the tracer to project assembly information directly on the workpieces in the prefabrication area. And in this case, with CW Keller, it's about creating freeform, complex wall panels from bent wood. So a very interesting application. And then once you start producing and building a building, of course, the question is how accurate have the builders worked? Are all the objects in the position where they should be and in the place where they should be, in the quality they should be? And there we offer a software called Build It Construction, which allows you to take the laser scans you capture on site and in a very short, efficient workflow, do the quality control directly on site, be it floor flatness control like we see here, or wall plumpness or wall shape, or beam cambers like we saw it here in that example. And last but not least, to share all this massive point cloud data, we are offering a solution called WebShare Cloud, which is, as the name says, a cloud-based solution, which allows you to share all the scan data that you have, annotations and additional information with the stakeholders in your project. And based on an overview map like we see it here, it offers a very intuitive way to access the single scan positions. You can even show the status of your construction site at different points in time, like here in the raw building status, or on the next picture we will see how the same staircase looks like with the concrete on it. Sorry, concrete is the next picture. And you can view the data here in 2D views like we saw in the beginning, or in 3D views like you see it here. And the 3D view also allows you to freely navigate to complete construction projects in your scan data, almost like if you were working on a local workstation here. And as you can see, you can really quickly move and fly around and change the position. That's everything I wanted to show you. It was just a quick overview. If you want to know more, come by our booth down in the exhibition area, and we're happy to talk to you then. Thank you.